All right, 7-3, negative exponents. First, we're going to learn about our zero exponent property. So basically, any non-zero number raised to the zero power is equal to 1. Okay, so it doesn't matter what is inside the parentheses. There can be one thing inside the parentheses or, 8 things inside the parentheses. The whole thing is raised to the power of 0, so that equals 1. Now let's say you have a negative on the outside of your parentheses and is raised to the 0 power. Well, then that is negative 1. Let's say you have a 2 on the outside of your parentheses. Well, anything raised to 0 is 1, and 1 times 2 is, 2. Okay? Now, what if there are no parentheses and you just have a base with a power of 0 in and amongst some other things, all right? Well, what we have here is, we can group our bases. So you get a and 4 minus 2, and then b to the 0 power, we just learned that's 1. So a squared times 1, anything times 1 is itself. Okay, so your answer is a squared. Okay, that is our zero exponent rule. It's fairly self-explanatory. You can raise to the power of 0 is 1, and most people were pretty okay with this. But when it came to practice, they were a little hesitant, so make sure you ask. But it really is that simple. Don't make it too difficult. All right, so before we get more into negative exponent properties, because we delve into a little, we are going to talk about how you know when your expression is considered fully simplified. Because some of you are getting messages to simplify more, and you're not quite sure why. Well, here are some things you can check. You can check that it contains only positive exponents. Okay. We're about to show how to get rid of all those negatives, so you want to make sure all of the negative exponents are gone. Okay. Next up, this is a huge one. Each base can appear exactly once. This is a big one. You can't have a u on top and bottom. You have to decide if u is going to stay on top or bottom, not both. Okay? And then there are no powers of powers. All right, we learned that yesterday. Powers of powers would be like x squared, and the whole thing is squared. Well, that equals x to the 4th. You have to math it out. Okay? And then everyone's favorite fractions. All number fractions must be in simplified form. So if you have 2/16, you must simplify that to 1/8. Okay? So these, if you are being told to simplify more, these are some of the things that you should look for to help find your error. All right, now let's talk about our negative exponents. Basically what's happening is your negative exponent is telling you that whatever the base is, it doesn't want to be where it's at, okay? And so it's giving you some attitudes, being a little negative on you. And so you place it where it wants to go, and then it drops its attitude, it drops its negativity. All right, so for example, 3, -5, well, it's telling you it doesn't want to be a whole number. Okay, 3 is telling you it doesn't want to be a whole number, it wants to be a fraction. And so you make it a fraction by putting it under 1. And when you do that, your exponent drops its negativity. It's now happy. It's dropped its negativity for you. All right? So, and in contrast, if your negative exponent is in the bottom of a fraction, it's simply telling you that I don't want to be the bottom of a fraction. I want to be a whole number. Okay, so it goes from giving you some negative attitude, and once you make it a whole number, it drops its negativity for you. Okay, so let's do that in practice. Okay, simplest format. We have a cubed b to the -4th, and that is all divided by c to the -2 power. Okay, and they broke it out, like terms. And so I know I'm going to have fractions, so I'm going to write in my fraction bar. Okay, so a cubed, it's one term. It has a positive exponent. It stays on top. It's exactly where it wants to be. Now b to the fourth, it is giving you attitude. It does not want to be up here. It wants to be down there. So we will make it happy. And when we make it happy, it drops its negativity. Okay. Now on the bottom, we've got c to the negative 2 power. It is giving you attitude, all right? It has a negative exponent. It's telling you it does not want to be in this fraction format, so we're going to put it on top. And when we make it happy, it drops its negative attitude for us. Okay? So, again, negativity is just telling you that your base doesn't want to be where it's currently located. Okay? If it's a whole number and it's a negative, wants to be at the bottom of a fraction, and if it's currently at the bottom of a fraction, it wants to be a whole number. Okay? Or if you have a fraction and you have a negative on top, put that on the bottom. If you have a negative on the bottom, put it on top. Flip it. Let's put this into a bigger problem on the back. Okay? Put this on the bigger problem on the back. So let's check out this problem. So we are going to simplify 3g to the negative third power, h squared. And that is divided by negative 36g to the third power, h j to the negative fourth power. And we're going to assume our denominator does not equal 0. That's a very big deal. You don't want to divide by 0. That is irrational, and we can't math the irrational numbers, not at this level. So we are going to group our powers with the same bases. All right, so I'm going to draw my division line, and I'm going to spread out the top and the bottom so I can group what we have together. Okay? So I can group what we have together. Okay. Now, quotients of powers and negative exponents properties. Okay, so let's check this out. All right, we have, what are we going to do first? First up, we have this fraction here of negative 336. Okay, this is a negative because you have a negative in one part of this fraction. So the computer, just FYI, wants the negative out in front. You can also put the negative on top. Where it does not want the negative is on the bottom, so we will have to move that, okay, so out in front. So that gives us, okay, 330, so we can divide both of these by 3. All right, 3 divided by 3 is 1. That negative 36 divided by 3 is 12. Okay. Now let's check out our next grouping. Okay, so this negative 3 exponent is telling you that g, it's giving you attitude. It does not want to be up there, so we are going to group it down below and give g to the negative 3 on the bottom a buddy. Okay, so we'll deal with that here in a minute. Now the quotient powers tells you, okay, we're going to subtract top down. And where's it going to end up? Well, who has the most exponents? Well, it's the top. So the top gets your h. And 2 minus 1, because you subtract top down, is 1. Okay. And then j to the fourth is currently on the bottom. It is giving you some negative attitude. It doesn't want to be down there. So, okay, we'll put you on top here. There we go. Now, let's clean this up a little. We are definitely negative, okay? Now, that exponent of 1 we can make invisible. And the 1 we can also make invisible, all right? Because they are both given and they add absolutely nothing to our math problem, because anything times 1 is itself, and anything to raise to the first power is, well, itself. So we can get rid of those. And we are left with h, j to the fourth, on the bottom, 12. And we can only keep one of these g bases, and we add those exponents, and that is 6. So there's our answer, okay? Group them, take them one base at a time, determine where they want to be, then do either, you know, your product rule, your quotient rule, okay, your negative exponent rule, move it up. So those are our rules to follow. So we add when we are multiplying our bases, we subtract when we are dividing our bases, and when we have a negative exponent, we just move it to where it wants to be so it stops giving us attitude. All right, so we are going to take this and we're going to use what we've got, okay? We're going to use some of what we've got so far. And we're going to do something called order of magnitude, okay? So it's a concept, and it kind of is a little bit linked to our scientific notation we were talking about earlier, has some of the same math, okay? So order of magnitude is used to, well, to compare measures, that's one thing, and to estimate, and to perform rough calculations. So it's not precise, okay? We're doing estimates. All right, so the order of magnitude, okay, of a quantity is the number rounded to the nearest power of 10, okay? So we're doing some base 10 stuff. So our base will be 10, okay? And then we'll figure out what our exponent is. So, for example, the power of 10 closest to 105 million is 10 to the 8th power. Now we took our number and we moved it 1, 2, 3, 4, 5, 6, 7, 8. We moved that decimal place 8 places to the left, so it's positive 8. Or 100 million. So the order of magnitude for 105 million is 10 to the 8th power. Okay. So we are going to use some of the same skills that we did to apply this concept. We're going to do it with speed. So we have the maximum speed of this particular falcon is about 90 meters per second. The max speed of a garden snail is 1/100th meter per second, significantly slower, but these are both meters per second, so they are both like terms. And it wants to know how many orders of magnitude as fast as the falcon is the snail. Now this is another case where how many orders of magnitude as fast. All right, you may think you need to multiply, but what you really need to do is divide. Okay, so it's regarding is a snail, so it's going with the snail divided by the falcon. Okay, because the snail in terms of the falcon. Now remember, when we move our decimal to the right, it is a negative exponent, and when we move our decimal to the left, it is a positive exponent. All right, so we got those two rules. We learned those prior. So let's do our snail first. Our snail, okay, we're going to talk about our snail. The snail is 0.01, okay? We are going to try to move that decimal, okay? And how many times are we going to move the decimal? We are going to move it twice, okay? Now we're doing a base of 10. We moved it like we did scientific notation, so it was just one digit in front of the decimal. Well, we moved it twice, and we moved it to the right, so there's a negative exponent, okay? And that equals 1 over 10 to the 2nd power. Now, I had a couple questions about why I used a base of 10. Well, 10 squared is 10 times 10 is 100. Well, this would be 1/100th. Decimal is 1/100th. All right? That's how these base of 10s work. All right? And let's do our falcon next. Okay, falcon. I know sometimes math's weird. All right, so we're trying to do base 10, well, 90 meters per second. Well, that's close to 100. It's pretty close. We can make that falcon a little faster. Okay, that is why we are saying we are estimating and giving rough calculations and not precise. So we're going to say this falcon is 100 meters per second. Let's move our decimal 2 places, and we moved it to the right, so it's a positive exponent, base of 10, 2. Because 10 squared is 100. Okay? Now, we are doing snail over falcon. Snail over falcon. Well, snail over falcon. Okay. Well, doesn't want to be up here, so 10 squared made that happy. 1 over 10 to the 4th power. Okay, and if you want to make this a positive base 10, it would be a negative exponent. Okay, 10 to the negative 4th power. I did that for a reason. We're talking about magnitude, and so the magnitude is the exponent, all right? So our snail is negative 4th magnitude. So it is 4 times slower, basically, than that falcon. And so it makes sense. Your snail is much smaller, so it makes sense that it's a negative number. Okay, now I want to show you something. Okay, so let's put these numbers together. So we've got 100.01. Okay, now we moved the decimal here. Okay, and then we move the decimal back. 1, 2, 3, 4. Okay. So we had to move it this way first before we moved it back. 4. Okay. Anyway, just thought I'd show you something. All right, so your assignment is on Alex. It is 7-3, negative exponents. So make sure you use your notes. So especially when it comes to the 0 exponent property, use your notes. All right, remember you have to score at least a minimum of an 80 and show your work on paper. How do you show your work on paper with these? Write down the problem, write down what they equal. Okay? Now, write down the problem. Write down the problem, write how you moved things and grouped things, and then give me your answer. So, show your work, okay? Good luck.